So Reactlog is a memory leak by definition, so we have to opt into it. And we can opt into it using reactlog enable. And so I'll go ahead and enable that now. And then we can go ahead and run our Shiny application, no problem, just like we're used to doing. And this one is the old faithful example that we're used to seeing of all of the waiting times. And so we can change the bin count and the plot updates. Great. We can then view the Reactlog by doing Command FN3 for me, and it might be like Option or Control FN3 for Windows. I can't quite remember. But your Reactlog will show up in a separate window. And there's lots going on here, but for just quick look, we can see our input bins that we had on the left, and on the right we can see our output of our distribution plot, a dist plot from the application. And let's take a look. So the way that Reactlog works is it flows from left to right. And I kind of made the pieces so that they kind of fit in like a puzzle. So you can have your inputs here on the left, and they can join into your reactive values in the middle. So it joins in there and needs to be finished off with an output value on the far right. In this case, there is a theme counter here, but that's not having any outputs listen to it, so that's why it's all the way on the right. So we kind of align right on all of the values, but theme counter we can ignore. We're mainly just interested in the output of the dist plot. The Reactlog, if we look, let's just kind of walk through the top of this status bar. So we have the 8 navigation buttons at the top. The first and last are traversing between marked steps. We haven't done that yet, and we'll come back to that later. The next ones is a tall green bar. That's this tall green bar here, which is when Shiny was idle for at least a millisecond. It declared that it was idle. And then the short green bar is an output. So an output calculation, and you can jump between prior and previous outputs. So you may calculate 5 outputs and then Shiny becomes idle. So you may want to jump in between to see how your reactive updates. But the ones that I use a lot are these middle two, which is previous step and next step. And I don't like to use the mouse that often, so we can actually use the right arrow and left arrow. And you can hold it and you can hold it back. And the keycaster is showing that I was holding that there. So that's pretty exciting. Reactlog defaults to the first time that Shiny was idle because it doesn't actually know where you want to start. I find starting at the end was where I launched Reactlog was too far away because most likely I want to build up into the unexpected error or build up into what I'm trying to learn about the application. So I started it at the first stable location. And stable is kind of when most of the outputs, or in this case all of the outputs and reactive values are green. They're in the ready state. If they were not in the ready state and they're actually performing some calculations, they will be yellow. It's kind of useful to see these different states. In the future, I'd actually like to show more states, like a red for an error occurred or something like a rec false. But I was just trying to show currently what Shiny is aware of, because technically a rec false is a valid result, and so it's not calculating anything. It is actually ready to move on, even though the value is not what we want. So it'd be better in the future if we could differentiate those. So now we're at an idle, and let's take a peek at what happens when, remember, I changed the bins in the plot. So in the sidebar, I changed the this where the width actually changed, probably due to the width of the plot actually was changing, probably due to this little showcase mode on the side. And so 2 times the plot was redrawn because the output width changed. And so yeah, so let's walk actually through when I changed the int of the bins. And so I changed it from 30 to 21. And the way Shiny works is all downstream dependencies will be invalidated, and they will remove all connections, both up and downstream, from their connections. So it's not fully invasive, but it is invasive for everything downstream of this input value. So let's kind of walk through it. This will tell, so the input bins will say, hey, all my downstream listeners, you are now should start invalidating. So plot output, or plot obj will start invalidating. He's going to tell of his downstream dependencies, which is going to be the output dist plot. Output dist plot says, okay, I will start invalidating. They will start invalidating by removing all upstream dependencies. So the black lines are now becoming thin little lines. The thin lines I kept in there to say a connection has occurred in this recording, but it is currently not there. Where if it's a thicker line, then that means it's actively a dependency. Okay, dist plot has removed all connections and it is invalidated. So now we are backing out of our invalidating process, and plot obj will remove its last dependency and is now finally invalidated. And then the input value is done, and so we'll just automatically jump over into the next step, which is the output starts calculating. Shiny works in a model where it finds all the data that it needs to render. It is not necessarily a push model. So I did not push input bins into the plot object. It's actually the plot object is reaching up and finding input bins. It's a little different than the way we think about it. It's because of the two different steps, where the first part was input bins tells all downstream to invalidate, but then it's a free-for-all. Finally, now output dist plot can then work its way upstream until it's satisfied. So output dist plot starts calculating, says, hey, I need the plot object. Plot object says, I haven't calculated, so I need to start calculating. Then it says, well, I don't have everything I need. I need a connection to, in this case, it's these unexpected 3 items here. The client data output dist plot width, client data output dist plot height, and also client data pixel ratio. These 3 pieces of information are necessary to draw an image in Shiny. And I think it's really neat because if you squeeze the plot, we should redraw it because it doesn't really look like it's going to fill the proper area. If you make the plot taller, we will want to redraw it so your output height and width will change. And then your pixel ratio is if you actually do like command plus or command minus, and you go to retina display or non-retina display, the quality of the image will need to be adjusted. And so in this case, plot obj is going to be retrieving those values via an isolate. That's why it has a dashed line. So it's isolating on the value. And then it removes the connection because an isolation does not have any reactivity. And then we get the pixel ratio value and the input bins. At this point, plot obj said, hey, I got all my values. I'm calculated. So we can go back to the dist plot and continue the calculations. In this case, dist plot does have a hard dependency on the output dist plot width, the height, and the pixel ratio. Mentally thinking, I thought it would actually be inside the plot obj, but it just happens to be in the output dist plot. Dist plot is now satisfied and it is done calculating. All of the outputs have now been calculated, so therefore Shiny is idle. Yes, it was. It happened at 11.45 and it's finished at 11.51, so 6/100ths of a second. Yeah, so the timeline across the top does not represent actual time, it represents steps taken. And so you can have many steps taken in a very short amount of time, and you can have hardly any steps taken in a very long amount of actual time. Such as when I go from this step, and so as we were talking about there, the time up here represents the time since recording or starting the application, and then the session represents what Shiny session it belongs to. Typically, when you open up a Reactlog, that session will be isolated to any global sessions such as Shiny idle, or any session that I am running in. So in this case, I'm running in the Shiny session 2D7 blah blah blah. And between these two steps, about 10 seconds had elapsed. So the Shiny was idle at the 1 second mark, and then we started changing the value 10 seconds later. And just a quick to show about switching between idles. So if you do, so if we click the button here, we can go back and forth between idle sessions. Most likely that's something where you know that you've done something within the application. The graph doesn't necessarily change because the app is fairly small. And the last one that I want to show in this is the searching. So you can search for these labels here. So in this case, I can search for, let's say, plot, and all the things that show up, or even capital plot. These three items all contain a capital P in plot, and this is a smaller app, so the searching isn't quite as effective, but if I did the lowercase plot, it's still the same graph because the ancestors and descendants are the same. Another way to go around this, I like to hit escape to escape that searching that was done. Another fun one is that you can single click an item, so it kind of shows up while you move around and do things, so you can see that one specifically. Escape to get rid of it, but what I like to do is to double click, and it will kind of make it bigger. It'll highlight it, and it will find all of its ancestors and descendants, its whole family tree. And when you move back and forth, it will only be for that tree that is displayed. So if there are other reactives, you have 1,000 other reactives above or below that aren't shown, we'll skip over all of them. So we'll only look at the reactivity for the subtree that is displayed. And that is really useful because when you have an app like Gradient, I think on load, it has about 2,500 reactive IDs created. Yeah, it's big. It's a very big app. It's wonderful for testing, by the way. Thank you. And has a lot of different corner cases. But yeah, it's a very large graph, very shallow graph, actually. I was very surprised about that. Not very many, dependencies, something like this, like 3 layers deep, but useful nonetheless. So let's look at a more direct example, looking at Pythagoras app. And I like to look at this one as an app that people aren't necessarily familiar with, because we know the Pythagoras Theorem. We know how to calculate it, but we can do this through reactivity, because if I change A or B, then my output C should also update. Just that's how the definition of the triangle is done. And let's look at the how we would calculate Pythagoras theorem. So to calculate that, we need to first calculate a squared. We can label it with a squared, and I highly recommend you giving anything that you can a label, because most likely you'll have a multi-line expression, and possibly your first few lines might be very similar to other reactive expressions. And so your default label is not going to be that useful. Instead, we know this is a squared, so I can give it a nice value of a squared. This is underutilized, but is very effective when viewing the Reactlog. So future you will thank you for your work that you do up front. So we have a squared, calculate. We then have b squared, and we calculate it. Great. Given these two reactive values, we can retrieve them, add them together to make c squared. And then finally, given c squared, we can take the square root of it and have our answer c. This value is then displayed via render text and also a render print, just so that we have more outputs to look at. But it could just be done with a single render print or render text. Okay, so let's run this application. In the top, I have a reactlog enabled to enable the reactivity. And then finally, I will call command FN F3 just to open up the viewer. So let's run the application. Cool. So this is a fun surprise. I skipped over it in the code. You don't necessarily need to always open up the viewer. Instead, what you can do is add a UI value and a server value. The UI value is Reactlog module UI. So it's a UI module that you can add into your application just so it's inserted in, the Reactlog is inserted in, and you don't need to open up in multiple pages. But to pair with this, we need to have the Reactlog module server so that we can update those values in the UI. It won't magically just occur. Shiny needs to be told that these things can be done. So that's where that's coming from. So in our application, we have our A, we have our B, and we have our C. You know, output C and output C, two different outputs. And the Reactlog looks like this. So we have A to A squared, B to B squared, A squared and B squared make C squared. C squared can be square rooted into C, and C is then stored in the output C verbatim and C text. And that matched exactly how we had in our application. Input A to A squared, input B to B squared, A squared and B squared point into C squared, and the square root of C squared makes C. And that matches our labels. Everything is nice and tidy, and we can see our images right in the app. Very exciting. You'll notice that there's this extra item of a theme counter. That's for things like Bootstrap lib, where we update the theme and do things like that. You can feel free to ignore it. It's not a big deal. And then this extra line here is the Reactlog module UI and the iframe, because this is actually an iframe to the Reactlog information. So we can just kind of feel free to ignore that. That's not a big deal. Okay, so let's look at what happens when we change this to 5 and 12. We get the 5, 12, 13 triangle. Great, not too big of a surprise. Let's refresh our Reactlog because that more reactivity has occurred. And it only loads it up to the first time when we did the application when it was idle. So we can walk through this application using our arrow keys. And when we change the value, A went from 3 to 5. So all the downstreams get invalidated. And they're invalidating by removing all of their dependencies and marking themselves as invalidated. And then they work their way back up. And B squared was not a direct dependent or descendant of A. So therefore B squared will keep its value, but it will just remove the connection from B squared to C squared. C squared is actually initiating that removal of the connection. And so B squared is going to stay calculated, and if you were to ask its value, it would return immediately. It would not need to recalculate because it was not invalidated. And then once all of those invalidations occur, Shiny sits there and goes, okay, what outputs need to be calculated? And we'll walk through that again. So C verbatim says, hey, I need a value. It captures C. C needs to work its way up because it doesn't have a value. A squared works its way up, gets A, calculates its value. C squared is now happy with A squared, but it also needs the B squared. B squared in this case has already been calculated, so it returns its value immediately. No time is spent calculating B squared. And up the tree back down to C verbatim. C verbatim is happy, but we still have more outputs to calculate. So we'll move on to C text. C text will then look at C and say, hey, I need your value. C will be like, great, here's my value, we're done. There's no more calculations needed. Shiny has this automatic kind of caching value already done. And so if a reactive value has not been invalidated, it will return its value immediately and no time is spent calculating that. And I think that's just great. Like, it's a neat little trick hidden underneath. And if you were to add an output dynamically, like right now, and all it needed was the C value and B squared, it would be instantaneous. You wouldn't have no extra overhead, and that is great. And then we're done. Shiny is idle. But we also then updated the value to 12, and we ran through the same process again, but we went up the B branch instead of the A branch. Done. Shiny is idle. And then the next steps actually are me clicking the refresh button and then the iframe updating. When you click the refresh button though, it will always go back to that first idle location. And the Reactlog is append only. I don't cut it. I don't do anything special. I just append on because I don't want to hide the truth from what's there from you. So what you can do is actually mark a time point. And I find this really useful because most likely in your Shiny application, you will have to do many steps to possibly get to your bad reactivity. And then you'll say, hey, I need to like mark this time point because I know the next steps that I do may be a little, wonky. So to mark a time point, you can do Command Fn F4, or a little bit more reliable, given your browser, you can do Command Shift Fn F3. So very similar to Command Fn F3, but you add in the shift. And what this will do is it'll mark a time point. So when we refresh our application, it won't load to where it's first idle. It'll load to the last marked time point. So you can have many marked time points, but it'll load the last one. And this is really nice because if we go back to like a 3, 4 triangle, right? So 3, 4, 5, and then I refresh. It was loaded up before I hit that before refresh, and so we can go. And I'm sitting in a 5, 12, 13 triangle, and if I were to move forward, this is now running through and converting it back to the 3, 4. So right where I had last marked my time point. So for completeness, I'm going to do another marked time point, and I'm going to refresh the Reactlog. So you can see the marked time point down here, and I can actually jump between them using the black bar, because that is a marked time point. Maybe we should remove them unless they're there, but I thought it was kind of to help show that it's possible that they could be there. Okay, so let's look at a situation where Reactlog will help us debug our reactivity. We had our Pythagoras application here, and now let's look at a broken one. So the difference between Pythagoras and Pythagoras broken is not that much. The app will run and no errors will be produced. This is actually terrifying because this means it's a logic error and it is not actually a Shiny error. So let's go ahead and run the application with our Reactlog enabled. All right, so we're running our application. Great. So what is going on here? Our C value is 4.2. It is not a 3, 4, 5 triangle. And C squared is listening to B squared sometime because there's a connection being made, but it's not solid. And and B squared is listening to A? This is weird. So let's change it to a 5 and a 12. Still 7. Okay. So odd. All right, so let's look at this application. So did actually it change? Yeah. If I change B, nothing happens. So this isn't good either. So walking through the Reactlog, let's kind of see what happens here. So this is when I was changing it into that 3, 4, 5 triangle. So A changed into, or 5, 12, 13. So A changed into 5, great. A is telling B to invalidate, that seems odd. So, oh, there it is, input A is B squared. We should switch that. So that is now B. So personally, that's a better logic change. Let's just rerun the application here. So we'll run app again. Okay, things are looking better. Let's switch this to a 5, and then we switch this to a 12. And B is still broken. That's not good. But we can see that B squared is taking an input from B, so that seems better. So we're doing better there. So let's walk through that adjustment. So given that adjustment, A turned into 5, A squared, C squared, okay, everything's good. Seems right. Output C verbatim is recalculating, getting its A squared, and C squared is isolating on B squared, odd, and moving on. Okay, so there is that's how that connection was made at some point, but it's not connected right now. And I guess that's why it makes sense that when B changes its value all the way up to anything, like 20, C is not changing. So, isolate value here. We remove that B squared. Great. So we'll save it. Let's kill the application because we made a known logic change that's better. And things, I believe, will be good. So 5 and 12. 5, 12, 13 triangle. And if we refresh our Reactlog, we can see that A makes its updates, and we can also see that we change B and it'll make its updates. And C was actually updated twice, which is what we want for all the changes of A and B, and shiny is idle. Ta-da! So that's how we can use it to help debug, and it's helped debug logic changes, and this works really well when your application is very large, because this can work with, you know, a couple thousand of these different reactives, no problem. Just to show a bigger application, I'd like to look at the CRANwhales demo app that Joe showed at one of his keynotes. So again, we're going to make sure that Reactlog is enabled. We're going to run the GitHub one application, and this application shows the top N downloaders of all of CRAN that's hosted by RStudio. And it's usually the 80-20 rule, where like 6 people are responsible for a lot more than 20% or 80% of the traffic, you know, depending on the day. So we're thinking about it here and downloading that data. Great. All right, so the data is shown up. We have some numbers up at the top of the bandwidth consumed, the files downloaded, the unique downloaders. So out of the 120,000 unique downloaders, the green bars are represented by 6 people. So these are the whales, and so it's the CRANwhales. And yeah, that's almost 50% by those 6 people. The biggest whales are given random names, and so the full puppy, he's the biggest whale. And by hour is actually very interesting. There's different behaviors. Full puppy looks kind of like internet traffic. The glamorous parakeet, pretty consistent. And the glamorous fish, very spiked behavior. And immense zebra looks very constant. So it's very interesting to see as to how these different behaviors come about. And then we can look in the detailed view of, let's say, full puppy. And it's doing some calculations. And either way. Yeah, so moving on now. So let's look at the Reactlog. So the command fn f3. This is a lot bigger. We have so this is the first time that Shiny was idle, and we are looking at remember on that home screen, we had 3 numbers up at the top and a plot. So we have our outputs that have calculated. We have the total size, okay? We have the total count, and we have the total number of downloaders. Great. And then finally, there's this plot output called all hour. And I'm recognizing this as a plot because it's listening to the client data pixel ratio, the height, and the width. And there's a plot object as well. So that's kind of like the shape of an output plot. These all listen to a data set called whales, which listens to the top n, or the top count, and also what date. And I think that's really kind of neat that you can see your data, everything's kind of pointing to these whales, and then things come from there. So we can actually look, yeah, so it's neat. Then the next thing that I did is I clicked on the second tab. So the second tab will start, and let's see here, and this will calculate output downloaders. So output downloaders then says, hey, I now exist, so let's make a plot, because the output downloaders wanted to look at the biggest whales. It's just a single plot, and it runs through, gets the plot object gets all of its information, and it pulls out the whales. Whales is already calculated, so we don't need to recalculate it, so it just takes the value right away, and then the output downloaders is done. And then this happens again for the next 2 or 3 tabs. Oops, I was hovering, sorry. And then the detail size, detail count, detail unique, because the whales by hour, detail view. It was a very big plot. Took a little bit of time to show up, but we had the given full puppy. This is the traffic that they were doing. Very funny. Not very many 1800 unique packages, but downloading them constantly. So someone had a wild true download file. Yeah, so we're going to go through here. So that's how the plot information will show up for that one piece of information. And if you noticed, there is actually a blue state, a frozen state. And that's what happened with one of the input values that we froze. So let's zoom back, see if we can find it quick. There it is, frozen. This input details was frozen because we're trying to avoid a situation where if you open up a new view, but you haven't had all of your selected values like actually selected, then you may want to freeze that input value so that your plot doesn't error out. You can do this with maybe like a rec false instead. That would cause it to update once the input value does, but you still may need this special case of frozen. So if this does, like if you have this funny situation with plots and you can see it just for a quick second, maybe check out something about freeze reactive values, and you can see more information in the docs there. It's a rare situation, but it does happen. And then last, I want to show that ability to do the subsets. So we were looking at all hour to begin with. That was that home screen. So we can double click on all hour, and all of the right and left keyboards, so I'm actually going to jump many steps in the Reactlog because nothing occurred on this subset. But if I back up just a little bit, then hey, everything starts updating quickly. Just to see these here, white values are reactive values that will exist eventually, but do not currently exist. So input count has not been touched up to this time point. And now it finally has at this time. That's why I kind of like to show it when it's first idle, because everything's kind of stable just for a little bit. One thing to look for with Reactlog, because you'll find some shocking behaviors every once in a while. And this is what Joe referred to as, in one of his talks, as an anti-pattern. And basically what happens is, if you observe on something, like an input button, and you use a render method inside an observer, this is typically bad. There are use cases, like you add a new tab where like it has completely independent reactivity. Cool, you should do this. But in this case, if I just want to render a plot to bad pattern, something that's a static name, and this expression will actually be evaluated many times, that is actually making new render plots over and over and over again. And that is bad. Instead, what we should do is calculate some data, such as click count, and call render plot, and wait until the input button has been clicked. So like, I require the input button to be not 0, and then I'll give you the input button. Like, that was the goal of this thing, such as when the button is clicked, render the plot. So instead we can say, make a reactive on input button that says you require it to be something truthy or non-zero. You'll have click count, and then we render the plot given the click count. If you really wanted to be dynamic and random, you could do it using a dynamic output ID. That's okay. That's kind of like inserting a new tab or doing something that has completely independent reactive logic. But the typical use case of like click the button, render the plot, this is bad. And we'll see it in Reactlog plain as day. So let's click the button. Okay, click the button. Okay, we got some new plots. Let's actually take a look at this Reactlog. And you can see that the Reactlog will get taller and taller and taller. And this is because we will have more and more outputs of output $bad pattern. So let's move forward in the Reactlog, and so we can see that this output bad pattern will be calculated at some point, and then it's finally calculated there. Great. You know, you don't really notice it off of one click, but what if we clicked it 1, 2, 3, 4, 5 times? And now let's refresh. Let's mark this time point. Marked. Great. And let's refresh our application. Now our Reactlog is a lot taller. And if we zoom in, we can see output bad pattern, output bad pattern, output bad pattern. There's 4 of these, 5 of these. And so I can search for that. And they're all making different plot objects, and they're all listening to the same inputs. So this is not good. And none of the output bad patterns exist at any one time. Like, they're not coexisting at any one time. And so this is an anti-pattern and something to avoid if you see it. It's not the worst, but it does, it will cause issues after hours and hours and hours.